Hello everyone, my name is Xichen Yu, and today's my topic is how Bayes' theorem is applied in machine learning. And first I'm going to introduce who is Bayes. Thomas Bayes was an English theologian and a mathematician that belonged to the Royal Society, which is the oldest national scientific society in the world and the leading national organization for the promotion of scientific research in Britain. Here I'm going to introduce you the basic logic of probability. First is the simple space. The simple space is a set of all possible outcomes of a random experiment. Second is the event. An event is a subset of the simple space representing a particular outcome or a combination of outcomes. For example, if a roll dice, six-sided dice, there's 1/6 possibility that you roll to get the one of the each six side. And for the second one, if you want get the even number of the dice, it's 50%. Here's the basic probability of the computation rule. First, it's a complement. The probability of A reverted it equals to the 1 minus probability of A. And second is independence. Just times the probability of two events equals the probability of two events happen together, and the conditional probability. Multiplication rule and the addition rule, which you are probably familiar with. Now I'm going to introduce the Bayes' theorem. This is the basic form of the Bayes' theorem. PA given B represents the conditional probability of event A occurring, given that event B has already occurred. Then PB given A is the opposite. And the Bayes' theorem is a conditional probability. It's used for calculating the probability of a hypothesis being true, given that a certain event has happened. So I can show you an example of how Bayes' theorem is calculated. And what does the calculation mean? Suppose event A, you have the disease, and event B, you test positive for the disease. And the probability of two events is already known. And we use a calculation of the Bayes' theorem. We show result that PA given B is 16.5%. And what does the result mean is you have the probability of 16.5 to have the disease when you test positive for the disease. And here's how Bayes' theorem applied to machine learning. Improve classification accuracy with naive Bayes for text and sentiment analysis, and quantify uncertainty in models with Bayesian parameter estimation. Optimize hyperparameter efficiently using Bayesian optimization. Detect anomalies for fraud detection and quality control. Embrace probabilistic modeling for better decision making. So I'm going to show you a real-world application to predict a heart disease using Python. Here's the steps I'm going to take to do the real-world application. Here's the part of the CSV file and what does each column mean. First, I'm going to do a data cleaning and processing. Luckily, we don't have any non-column, so we don't have to use the KN method to calculate the value we are lacking. And we do a feature selection, and we based on our ANOVA F-test scores. These are the top 5 features we're gonna focus to calculate what's caused the heart disease. And these are the 5 main elements that might cause heart disease. First is the ST depression induced by exercise relative to rest. And second, exercise-induced angina. The third is chest pain type. And fourth is maximum heart rate achieved. The last one is number of major vessels colored by fluoroscopy. Well, going to do a train test data split. So first we can set the training model to 80% of the data. Then the test model going to be to 20%. Then applying the Bayes theorem. So according to the heat map, it represents the confusion matrix, the number of true positive and true negative predictions. See, true positive is 75, false positive is 27, and false negative is 14, true negative is 89. And I'm going to introduce you the accuracy calculation, the receiver operating characteristic curve, which we'll be mainly looking at is the area under the curve, which is the accuracy of our results. So from this graph, we can see that our area is 0.87, so our results at 80.7% accuracy. So these are the advantages of using Bayes theorem in machine learning that I summarized. So lastly, we changed the test data to 10%, which means that our training data will going to be 90%. We're going to see our accuracy, the confusion matrix temperature of the true part becomes higher, and our area on the curve is now 88% accuracy. And my conclusion is mainly about the Gaussian if-based classifier effectively used Bayes theorem to predict heart disease with 80% accuracy, which is pretty high accuracy. With more data we can train, we can always get more accurate prediction, as I just showed. And it is a really simple model with higher accuracy with less calculation. And we can just clearly see our results through the receiver operating characteristic curve. And these are the three sources I do the research and where my dataset comes from, if you are interested. And thank you for listening.